Hello, welcome back to Beginning Algebra. Today we're in section 5.5 and we're going to be talking about multiplying polynomials. So specifically we're going to look at how to multiply monomials, then we'll multiply a monomial by a polynomial, and then we'll talk about how to multiply two polynomials together, and then I will show you what's called the FOIL method, which is just an alternate way of multiplying two binomials together. Let's get started. Now, first of all, in order to multiply monomials together, we'll need the product rule for exponents. And we actually have done this kind of thing before. We saw a problem like this back in section 5.1. So here we have 8m to the second power times negative 9m to the first power. Remember that when there's no exponent explicitly written, that exponent is understood to be a 1. So to multiply these two monomials together, we'll multiply constant times constant and variable times variable. So 8 times negative 9 will be negative 72, and then m squared times m would give us m to the third. So I hope you can see how all four factors here are multiplied together. We have 8 times m squared times negative 9 times m. So it's all multiplication. And when we finish, these factors are multiplied together. So we end up with negative 72 times m to the third. Let's try that same approach here on part B. We have 4x to the third times y squared times 2 times x squared times y. So we'll multiply the coefficients together. 4 times 2 is 8. Then we'll multiply the x's together. And to do that, we add the exponents. So x to the third times x to the second gives us x to the fifth, and then y to the second times y to the first gives us y to the third. And that is how you multiply monomials. Now, if we want to multiply a monomial by a polynomial, we'll use the distributive property and the product rule at the same time. So here in example 2, the instructions say find each product. So we will be distributing 4x squared into this pair of parentheses. So we'll have to multiply 4x squared times 3x, and then we'll do 4x squared times 5. 4x squared times 3x would be 12x to the third, because 4 times 3 is 12, and x squared times x is x to the third. Now to do 4x squared times 5, 4 times 5 would be 20, and then times x squared would give us 20x squared. Now, notice that when we first started the problem, the parentheses contained two terms. And after we distributed the 4x squared, our expression still contained two terms. So no matter how many terms you start with in your problem, after you distribute your monomial, you should still have the same number of terms. Now let's look at part B. We'll multiply negative 8m to the third times 4m to the third plus 3m squared plus 2m minus 1. So we'll just be multiplying negative 8m to the third by each of these terms individually. So negative 8 times positive 4 gives us negative 32, and m to the third times m to the third gives us m to the sixth. Now we're ready to multiply negative 8m to the third by this second term. So negative 8 times positive 3 gives negative 24. I'm going to write minus 24. Then m to the third times m to the second gives us m to the fifth. Now we're ready to multiply negative 8m to the third times positive 2m. So negative 8 times positive 2 gives us negative 16. M to the third times m gives us m to the fourth. And now we have negative 8m to the third times negative 1. So negative 8 times negative 1 is positive 8, and that's going to be multiplied by m to the third. Notice again how distributing this negative caused each term to change sign. So this 4m to the third was positive, but after we multiplied it by this monomial, it was negative. This term was positive, it ended up negative. This one was positive, it ended up negative. And this one was negative, it ended up positive. So distributing a negative will always, of course, have that effect. All right, now let's multiply the monomial 4/3 x by the polynomial 3 plus 2x plus 5x to the third. I think because we're distributing a fraction, I'm going to take an extra step that we don't normally take. And once you are comfortable with this, you can leave out this extra step. But I think the first time we go through it, it will be helpful for you to see this step. So I'm going to distribute the 4/3 x, but I'm not going to actually do the multiplication yet. I'm going to write down 4/3 x times 3, then plus 4/3 x times 2x, then plus 4/3 x times 5x to the third. Now let's go back and work each of these multiplications. On the first one we have 4/3 x times 3. Notice that a 3 in the top and a 3 in the bottom will cancel each other out, and so all that's left for this term is just 4x. Now let's look at 4/3 x times 2x. So we know that we have to multiply 4/3 times 2, and you know that when you multiply fractions, you just do top times top and bottom times bottom. Now there's no denominator showing here, but of course it's understood to be 1. So for the tops, 4 times 2 is 8. For the denominators, 3 times 1 is 3. And for the variables, x times x is x squared. And then finally we'll multiply these last two monomials together. So again, 4 times 5 is 20. 3 times 1 is 3. And for the variables, x times x to the third is x to the fourth. And so here is our final polynomial. If this fraction could be reduced, we would be responsible for doing that. But 3 and 8 do not share any common factors. So this fraction will not reduce, and this fraction also will not reduce. And keep in mind that the very last thing you want to do ever is convert these back to mixed numbers. All that does is introduce confusion. So it's really best if you come up with improper coefficients, just leave them as improper fractions. Now we are ready to multiply two polynomials together. So the strategy here is to distribute each term in the first polynomial to each term in the second polynomial, and then combine like terms. So let's practice that with example 3. So we're going to multiply m squared plus 5 times 4m to the third minus 2m squared plus 4m. So what we're going to do first is distribute the m squared to each of these three terms, and then we will distribute the 5 to each of these three terms. Then there will be some like terms, and we'll combine the like terms. So here we go. Distribute m squared, and for the moment pretend that the 5 is not even there. So m squared times 4m to the third is going to make 4m to the fifth. M squared times negative 2m squared is going to make negative 2m to the fourth. And m squared times 4m is going to make 4m to the third. Now we'll go back and distribute the 5. 5 times 4m to the third will make 20m to the third. 5 times negative 2m squared will make negative 10m squared. And 5 times 4m will make 20m. Now we have all of these terms here, and we need to just combine any terms that are like terms. So I see that my highest power is 5, so I look through the other terms and see if I have any more m to the fifth, and I do not. So the first term will be 4m to the fifth. And then my next highest power is m to the fourth, and I don't see any other m to the fourth, so I'll just have minus 2m to the fourth. And then we have m to the third. Now I do have two terms that are m to the third. So 4m to the third plus 20m to the third, remember we're adding here, is going to give us 24m to the third. Do you see the difference between multiplication and addition? Because these two terms are added together, we add their coefficients and the powers on the variables stay the same. Then we have our m squared term and our m term. So we end up with 4m to the fifth minus 2m to the fourth plus 24m to the third minus 10m squared plus 20m. Here is a similar problem for you to practice on. This would be a good time for you to pause the video and try this by yourself. Now I'll go through it with you. So first I'm going to distribute 6p to the second into this second set of parentheses. So 6p squared times 3p squared gives us 18p to the fourth. And then 6p squared times negative 5 gives us minus 30p squared. Now I'll distribute the 2p. 2p times 3p squared gives us 6p to the third. And 2p times minus 5 gives us minus 10p. Now distributing the minus 4, we get minus 12p squared. And then negative 4 times negative 5 gives us positive 20. Now look for like terms. I see that we have an 18p to the fourth. And then looking for third powers, I see that we have 6p to the third. And then looking for second powers, I see minus 30p squared and minus 12p squared. Together they make minus 42p squared. And then we have our p term, which is negative 10p. And then we have our constant, which is plus 20. Now, if you're multiplying two polynomials together that have several terms, your answer is going to end up with lots of terms. So if you're going to have a lot of terms to combine, it might be helpful to you to line them up vertically. So let's practice that here on this problem. We have 2m squared plus m minus 3 times m squared minus 4m plus 5. So first I'll distribute the 2m squared. 2m squared times m squared is going to be 2m to the fourth. 2m squared times negative 4m is going to be minus 8m to the third. And then 2m squared times positive 5 is going to be plus 10m squared. Now we'll distribute the positive m. So m times m squared will be m to the third. And notice I'm going to line up my 1m to the third under the other m to the third term that I already had. And now m times negative 4m gives us negative 4m squared. So we'll line that term up under its matching term. And then m times 5 gives us plus 5m. Now there wasn't already a column for the m terms, but it makes sense for this one to go here because you can see that what we've got is fourth power, third power, second power, first power. And now let's distribute the negative 3. So negative 3 times m squared gives us minus 3m squared. We'll put that here with the other m squared terms. Then negative 3 times negative 4m gives us plus 12m. And negative 3 times positive 5 gives us minus 15. Now we're ready to combine like terms, and it's very convenient because all of our like terms are grouped together in these columns. So we'll get 2m to the fourth, and then negative 8m to the third plus 1m to the third will give us minus 7m to the third. Then we'll have positive 10m squared minus 4m squared minus 3m squared. So 10 minus 4 is 6, and 6 minus 3 is 3. So here we have a total of positive 3m squared. Then here we have positive 5m plus 12m. That's going to be positive 17m. And then we have our minus 15 here. Now we're ready to talk about the FOIL method. And FOIL is an acronym. The FOIL method is just another way of thinking about the distributive property that we already have looked at. So the problems we're about to look at, you already have the tools to work, but the FOIL method is just an easy way of naming the parts of the binomials. And this FOIL method is only useful if you are multiplying two binomials together. It won't work on any other kind of polynomials. Your problem has to be two binomials for this to work. So as we go through these FOIL steps, let's just use these two binomials as an example. So we'll look at x plus 3 times x plus 7. The F in FOIL stands for first times first. So what they mean by that is take the first term in each pair of parentheses and multiply them together. So x times x would be x squared. And then the O stands for outer times outer. So what they mean by that is take these two outside terms in each pair of parentheses and multiply them together. So x times 7 would be written as plus 7x. Then I stands for inner times inner. So if the two outside ones are the outer terms, then these other two must be the inner ones. So 3 times x is 3x. And then L stands for last times last. So that means to multiply together the last term in each pair of parentheses. So that would be 3 times 7, so that would make positive 21. And then finally, after you use the FOIL method to get all of your terms, remember to combine any like terms that you have. So notice that our outer and our inner both gave x terms. So 7x plus 3x is going to be 10x. That's going to make our final answer x squared plus 10x plus 21. Now notice that the process we went through here is not any different than the process we would have gotten if we had just thought about the distributive property. Distributing the x would have gotten us x squared plus 7x. Distributing the 3 would have gotten us 3x plus 21. So the work is not really any shorter, and we didn't save any steps by using the FOIL method, but you'll find out in the next chapter that having the first, outer, inner, last vocabulary will really help us when we start factoring in the next chapter. So here's example 5, and we know how to do this using the distributive property, but let's just practice thinking through the FOIL method. First times first would be x times x, that's x squared. Outer times outer would be x times negative 6, that's going to be negative 6x. Inner times inner is going to be plus 8 times x. And then last times last is going to be positive 8 times negative 6, so that's negative 48. Notice again that our outer term and our inner term are like terms, so we'll combine those and we'll end up with x squared plus 2x minus 48. And here is example 6. So this one says multiply 9x minus 2 times 3y plus 1. Notice that both of these polynomials are binomials. That means we can use the FOIL method to multiply these together. So don't let the fact that we have two different variables here bother you at all. First times first would be 9x times 3y. So 9 times 3 is 27. And then we have times x and times y. And then outer times outer is 9x times 1. So that's going to be plus 9x. Inner times inner is negative 2 times 3y. So that's going to be minus 6y. And then last times last is negative 2 times 1. So that's minus 2. Now this time when we look at our terms and see if there are any terms to combine, we find that there are not any terms we can combine, because here we have an xy term, here we have an x term, and this one is a y term, and this one is a constant. So there's nothing to combine, and this will be our final answer. And now we are at example 7, so we'll use the FOIL method to find each of these products. Now that you're familiar with the FOIL method, if you would like to pause the video and try these first two on your own, I certainly would encourage that. Now I'll go through them with you. So if we look at this first problem, we have 2k plus 5y times k plus 3y. So this is, in fact, a binomial times a binomial, so we can use the FOIL method. And so first times first would be 2k times k, that's 2k squared. Outer times outer would be 2k times 3y, that's going to be 6ky. Inner times inner is going to be 5y times k. Now you might be tempted to write plus 5yk here, and that would not be wrong, but I want to encourage you that when you have two variables, always try to keep the variables in the same order in each term. That way if there are like terms, you'll be more likely to spot them. So 5yk I'm going to write as plus 5ky. And then last times last is going to be 5y times 3y, so that's positive 15y squared. Now look at your terms and see if there are any like terms, and we notice that our two middle terms are both ky. So that's going to give us 2k squared. 6ky plus 5ky will give us plus 11ky, and then 15y squared goes on the end. Now for part B, we have 7p plus 2q times 3p minus q. First times first would be 7p times 3p, so that's 21p squared. Outer times outer would be 7p times negative 1q, so that's going to be negative 7p pq. Inner times inner would be 2q times 3p. So that's going to be 6pq. Remember, we try to keep our variables in the same order so that our like terms will be obvious. And then last times last is going to be 2q times minus q, so that's going to be minus 2q squared. Always look at the terms and see if there are any like terms to combine. And we notice our two middle terms are like. So that's going to give us 21p squared. Negative 7pq plus 6pq is negative 1pq. So here I will just write minus pq, and then we have our minus 2q squared on the end. Now here in part C we have a type we've not seen before. So we have a monomial times two binomials. There are two ways to approach this. So you could distribute the 2x squared into this parentheses and then use the FOIL method to multiply binomial times binomial. However, I think it's always best to do the two binomials first. It just turns out to be easier in most cases. So you want to keep the 2x squared there, but let's go ahead now and use the FOIL method on these two binomials. So first times first would give us x times 3x, so that's going to be 3x squared. Outer times outer is positive 4x. Inner times inner is negative 9x. And last times last would be minus 12. Now still, before we distribute, let's combine our like terms in here. So I'll still have my 2x squared out here, but inside the parentheses I'll have 3x squared. Then 4x minus 9x will add up to minus 5x, and then we have our minus 12. Now, as our last step, we're ready to distribute this 2x squared. So 2x squared times 3x squared is going to be 6x to the fourth. 2x squared times negative 5x is going to be minus 10x to the third. And 2x squared times minus 12 is going to be minus 24x squared.